Engineers, problem solvers. Engineers, today we're going to work on a hands-on activity. So open up your science books to page 168. Page 168 is called Tik Tock. And no, it is not that kind of tick tock. It's like the ticking tock of a clock. Here's the objective, our goal. Collaborate or work together to investigate variables in pendulums. The length can be short or long. The weight can be heavy or light. Do they move at the same speed or different speeds? Remember, a pendulum is something that swings back and forth, back and forth. We're going to make our own today. So the first question underneath the objective is, what question will you explore to meet this objective? And here's the question. Do different size washers of pendulums affect the movement of the pendulum? What I mean by that is we're going to be working with washers. I'll show you what they look like in a minute. And we're going to use a small one and a large one. And we want to find out if that changes the way it swings. If it's bigger, does it move faster or slower? If it's smaller, does it move faster or slower? So take a minute to pause this video and write this question down underneath the objective, and then we'll continue on. Materials: scissors, string, meter stick, small metal washer, large metal washer, and timer. If you're in school, I'll be providing those materials. If you're at home, try to use something around your house. Otherwise, just follow along in the video so that you can see some of the things that we're going to be doing. Step 1. Be careful using scissors. Work with your partner, your think, pair, share partner. Cut 2 pieces of string, each about 40 centimeters long. Knot one end of each string to a washer, forming 2 pendulums. Well, you won't have to do this because I've already done this, so this step is done for you. But what I want to point out is this right here. This is a washer. This is a large one, and this is a small one. Remember, we're looking at them because we want to know if the size of the washer changes the movement. So step 1 has a question. It says, why are you preparing 2 pendulums? Is it to compare the effect of the string length on the pendulum? Or is it to compare the effect of the washer size on the pendulum? Yeah, it's to compare the effect of the washer size on the pendulum. So pause this video to write this sentence right here on step number 1. There is a line or two for you there. So pause the video to give yourself time to do that. Step 2. We're not going to do this yet. I want to explain some things to you, so listen before you go get your materials, okay? So step 2 says hold the string of the smaller pendulum so that the pendulum length is 10 centimeters. So they're holding it up here and they're letting it dangle from the desk because what they're going to do is actually let it swing back and forth, back and forth. So you want to make sure that when you do this, you're doing it just like that. But don't start yet because I want to explain some more things first. So before you do that, make a prediction. How do you think the motion of the pendulum with the smaller washer will differ from the one with the larger washer? Okay, this is step number 4, correct? Let me make sure. No, it's not. It's step number 2. I'm sorry. So on the bottom of page 168, you're going to make a prediction. Choose one of these to write down on step number 2. Okay, it's your prediction. Do you think the larger washer will go slow or the smaller washer will go slow? That's up to you. So pause the video to write your prediction on step number 2. All right, step number 3 is explaining the actual activity. But again, before you grab your materials, I want you to understand all the steps first. So it says pull the washer to the side and release it. So you would pick this up and let it drop so that it swings back and forth. Notice their hand's not moving though. This is what's going to move. What you're going to do is use your timer and let the timer go for 5 seconds. And you're going to count how many times it swings. It says one partner should hold the pendulum while another uses the timer. So one of you is timing, one of you is holding, and then of course you switch. We always switch. Before you do this though, I want to explain something because we're going to do this a couple times. So first you're going to do it at 10 centimeters. That's the length there. You'll drop it, let it swing, count how many times it drops, or I'm sorry, how many times it swings. And then you have a chart, it's on step number 6, that you're going to fill in. So pretend that the small washer swung 20 times. I would write 20 here. Then I do the large washer. I let it swing for 5 seconds, same length, I don't change the string. And then it swung for 20 times, I'm sorry. Then I would go back up here and I would adjust the length to 20 centimeters and I let it swing back and forth for 5 seconds. And I count how many times it swings and I go back to my chart and I fill that out. So 10, 20, 30 centimeters. You're filling out this whole chart, counting how many times it swings back and forth and back and forth. So your numbers aren't going to look like mine. This was just an example. Again, before you do that though, I want you to notice some of these steps. Step number 4 says, predict how using the larger washer will affect the pendulum swing rate. Write your prediction here, then repeat steps 2 and 3 using the larger washer. So on step number 4, you're just making a prediction. So your sentence starter is I predict. I predict, and I want you to predict what's going to happen if you use the larger washer. Will it be the same or different than the smaller one? How will it be different? Pause the video to answer that question. Okay, step number 5, one more prediction. Predict how making the string longer will affect the swing rate. Choose a distance between 10 and 30 centimeters, which is 20 centimeters. Write that number on the data table. Hold the string so the small washer's pendulum length is that distance, and repeat step 3. Do the same using the larger washer. Record your data in the table below. So step number 5 has one more question. How will making the string longer affect the swing rate? So if I make the string longer, will the pendulum swing faster or slower? Make a prediction and write it here. I predict that making the string longer will make the swing go, and I want you to write faster or slower, your choice. Okay, so write that sentence, fill it in with the last word, and then hit play so you can continue this video. All right, step 6, now it's time to actually do this experiment. So work with your teammate and your pendulum and start with 10 centimeters, then go to 20 centimeters, then go to 30, and see the swing rates on this. Remember, 5 seconds, and you're counting how many times it swings. When you're done with your chart, I want you to watch video 2 so that you can work on analyzing your results. Okay,